All right, welcome back to graphing polynomials. This is part 3, and we're going to look at something called multiplicity. And to kind of illustrate what multiplicity is, I'm going to compare two equations here. Say you were asked to graph y equals x minus 1. And over in this side of things, we're going to graph y equals x squared minus 2x plus 1. Okay, so two graphs. Now, I'm just going to show you what the graphs look like. Okay, just do a very simple version of it here. Okay, so in this graph, we recognize, oh, this looks linear. And we can see that it's got a slope of 1 and a y-intercept of -1. So if I just very simple little version of the graph here, we have a y-intercept of -1 and we have a slope of 1, so it looks like it's going to go up and through there, like so. Okay, so there is that graph. And then over here, if we were to go and graph this, okay, and by the way, if you use completing the squares here, another version of this equation, which might be easier to follow, looks like this. It would be x minus 1 all squared. So you go, oh, okay, so in other words, it's touching here at this point, and it's a parabola that actually looks like this. Okay, this side opens this way, and this side opens this way. Okay, here's the scoop. Here's what I want to get at. If we look at the x-intercepts on these guys, okay, x-intercept, we go, okay, yeah, this line has an x-intercept at 1, 0. Perfect. What about over here? It has an x-intercept also at 1, 0. Oh, okay. So if I didn't show you what the graphs looked like, you know, how do you distinguish between these? Well, really what we have happening here, and maybe in this factored version you can see it, it's kind of like we have two x-intercepts. They just happen to be the same. Okay, so when we say that the x-intercept is 1, 0, if you look at it over here, it's kind of like saying, yeah, we've got an x-intercept of 1 and another x-intercept of 1. So it's kind of like, yes, there's actually more than one x-intercept floating around. It's a repeated root is what we say. And so even though technically there is only one root, but it is a repeated root, so we say that is multiplicity of 2. Okay, whereas over here, you only have the one single point, and when you go back to this version, there is clearly no second x-intercept. It's a 1, and it shows up only once, so this has a multiplicity of 1. Okay. All right. Now, how does that help us if we want to try and do a reasonable graph? Okay, so let me just clear the screen here. And let's say in my first example, let's see here, we might try and do something like, we're going to graph roughly, and I say roughly because without graphing software or graphing calculator, these aren't necessarily the most accurate graphs. They're going to be really close, but they're not going to be perfect. Okay, so here's what we got, a little bit of a polynomial, but at least it's served up in a factored form. Okay, so now what I can do is make a bit of an analysis. What I can see is that we have a 0 or a root or an x-intercept. I think I'll just call it x-intercepts because that's kind of the most accurate, at -2. Okay, and we also have 1 over at 1. Okay, well that looks pretty good, but here's the scoop. This guy over here, there was kind of like two of them here, right? Because it was an x plus 2 and another x plus 2. So there's actually a multiplicity here of 2. Okay, multiplicity of 2. Often when you get an even number of x-intercepts or roots, it's referred to as being an even multiplicity, whereas over here the multiplicity is of 1, so it's odd multiplicity. So if you run into the terms odd and even, it just means the multiplicity is an odd number, whereas over here it's an even number. And what does that actually mean in terms of the graph? Okay, well, let's get I'll just do a very simple grid here. Actually, I'm going to use this line draw thing and make a more accurate version. A better job, as it were. Okay, so there's a rough grid, and at -2, okay, we know that this thing is an x-intercept, and at +1, it's an x-intercept. And we also know if we were to expand all this out, okay, and I'm not worried about coefficients, but I would end up with an x squared from all of this stuff times this x. I would expect to see an x cubed and then all the rest of it. Okay, I don't even care if I got a coefficient here, although in this case I don't. But what I do care about is, oh, it is a positive x cubed. So I know my rough shape of the graph is this. Okay, so how can we explain what's going on here? You know, how can I come roaring up, and then maybe it looks like I'm going to cross over here, and then but I can't cross again because I don't have any other zero. Well, that's where this multiplicity stuff kicks in. When it is an even multiplicity, then what we say is it just touches. Okay? It doesn't go roaring through. It comes up. We know that this is the basic shape of the graph, but when we get to the to this point here, it just touches. It doesn't go roaring through. So down on this side and down on this side. Okay, and that's because it is multiplicity that's even. Okay, anytime you have even multiplicity, then your graph will just touch and turn right back around. Okay. Now, if I was to do one more thing here for greater accuracy, I think I would try and see roughly where is the y-intercept. Okay, let's have a little look. And I think I worked this out, and I think I got a pretty big number. But anyway, let's just go up here. If you put in 0 for x, you're going to get a 2 squared is 4, and over here times a -1. So that's not actually too bad, -4. So that tells me, okay, I'm down here, roughly here. Okay, so I'm just going to bring this guy down and turn it around. And here's where I don't really know if it's looped down a little further and then you just cross on the way up. I mean, without getting more points, it's a bit of guesswork. But I do know I cross here, and I do know I cross here. And because this is an odd multiplicity at this 0, I know it's not just going to touch and go back down. I also know that that's what the graph has to do. So as much as there's a lot of little guesswork going on here, you know what? That's a pretty reasonable guess as far as the shape of the graph. And I could sort of speculate. I've got a little bit of a local maximum happening over here. And I've got, probably it's not exactly at this point. My guess is because of symmetry, it might be somewhere more down here. It probably goes a little lower and then cuts around. But this is pretty close to where there is a local minimum. Whoops. Okay. So that's where I'm going to stop for today. And we'll come back and try using our smarts to do another example. We'll catch you in a bit here.